This first one is called refraction. Now to prove this, I have a picture of a glass of water and a pencil. When light hits the water, it's going at a different speed than light goes and travels in air. So part of the light bends as the first part hits it, and as the second part hits it, it comes around and slows it down. Now, that causes refraction. The light bends, and you see here. That's also why when you're spearfishing and you look down into the water, fish are always a little bit closer or farther away from you than you think they are. My next couple of pictures will show that matter has different forms: solids, liquids, and gases. Now in our example here, water, you see the water flowing through in its liquid form. In the next picture, this one here, you see water in its solid form, known as ice. When water cools down enough to about 32 degrees Fahrenheit, it solidifies and turns into ice. Now this next one has to do with heat, specifically how heat transfers. Now, in this picture, you see a burner. On the burner is on high, and the heat is really intense. Now, in the next picture, you see a pan with eggs in it. Now, once the heat hits the pan through radiation, the pan heats up the eggs through conduction. Molecules hit each other, then bounce around, causing them to go faster and faster. This next one has to do with rainbows, and I'm going to use these tools, the flashlight and the CD, to create a rainbow. Now, rainbows happen because of reflection and refraction. Once the light, in everyday settings, once the light hits the rain, it reflects and refracts into the different colors of the rainbow. Now I'm going to use these tools to create a rainbow, and in this picture, you see that happening. In this picture, you see the effect. Once the light hits the CD, it reflects and refracts into the different colors of the rainbow. Now this one is going to be a little bit different from the other ones. This one's going to be done in a video game called Universe Sandbox. Now this is a highly accurate simulation game in which you can simulate things that happen in the universe. Everything from our solar system, you can see here, the Sun, Mercury, Earth, all that jazz, to galaxies colliding. Now this is what we're going to do. This one is simulating something that's going to happen in real life in a few million years. Well, 100 million years. This is the Milky Way galaxy. This is where our solar system lives. Now, this one is called Andromeda. In a few million years, these galaxies are going to collide in real life. Now, what I'm going to do is set this to 15 million years per 1 real-time second. We're going to watch what happens. As you can see, the galaxies are coming together, and they're colliding. Now, to make this go a little bit faster, I'm going to set this to be 25 million years per 1 real-time second. Now watch this. As the galaxies are coming apart, they're also circling back around. So you can see here and here, circling back around, and attracting each other back towards them. Now, as you can see, they're coming together, and they're coming back around again. Now this is caused by gravity, as you can probably guess. And lastly, we have this experiment. This experiment is designed to show the molecules move faster when they're hot. And to prove this, I have this setup. On the left side, we have a glass of hot water and a vial of red food coloring. On the right side, we have a glass of cold water and a vial of red food coloring. Now, I dropped 2 droplets of this food coloring at the same time into the 2 glasses, and in this picture, you can see the results of this. Now you can see on the left side how it's more evenly spread out and spread out more quickly on the right side. On the right side, it's sort of cloudy and muddy and not as spread out yet. And that shows that molecules move faster when they're hotter than when they're cold.